Can you picture Jupiter without any observable clouds or haze? It isn't easy since Jupiter's latitudinal clouds band and its great red spot are iconic visual features in our solar system. Those features are caused by upswelling and descending gas, mostly ammonia. After Saturn's rings, Jupiter's clouds forms are probably the most recognizable feature in the solar system. Today we will discuss with you about the twin of Jupiter, WASP 62b, which has no clouds. Welcome back to Signatures Life, and you're watching Signatures Science. Astronomers with the Center for Astrophysics have found a planet similar in mass to Jupiter, but with a cloud-free atmosphere. These planets are scarce, and astronomers think only about 7% of exoplanets are like this. The discovery allows scientists to study how they form without clouds, and this way, a clearer view awaits. WASP 62b is the nearest planet to WASP 62, a main sequence star almost 600 light-years from Earth. 62b is the only planet in the system. It's just over half as massive as Jupiter and orbits WASP 62 in about 4.5 days. It's about 1.4 times as large as Jupiter. It falls squarely into the category of hot Jupiters with an average temperature of about 1330 Kelvin, otherwise 1057 degrees Celsius, otherwise 1934 Fahrenheit. The planet's temperature, size and density properties are in rare. What's rare is the cloudlessness of its atmosphere. The WASP name comes from the wide-angle search for planets, otherwise WASP South. The planet was first discovered in 2012 and one of 7 hot Jupiters found at the same time. WASP 62b was discovered with WASP, but scientists used the Hubble to study it more closely. Using spectroscopy, they watched closely as the planet transited in front of its star 3 times, looking for potassium and sodium. As the starlight passed through the planet's atmosphere, they identified sodium's complete spectroscopic signature, but no potassium. The sodium signature told them that the atmosphere was clear. The focus on potassium and sodium is based on a couple of things. First of all, their spectra are easily observable in optical light. Sodium and potassium are 2 species that are readily observable in exoplanet atmosphere observations taken at optical wavelengths, and their presence or absence can help us infer if there are clouds or hazes in an exoplanet's atmosphere. Sodium and potassium also play a role in exoplanet atmospheres, though the details are unclear. Sodium and potassium are 2 elements that play an interesting, yet not well understood, role in the atmospheric physics and chemistry of exoplanets. The detection of sodium's complete spectroscopic signature tells astronomers that the atmosphere is clear, even if there is no way to see the atmosphere. Clouds in a planet's atmosphere will mask or obscure parts of the absorption line. In the absence of clouds, we can resolve the full sodium signature, which has a 10-like shape with a peak at the core of the absorption feature and broad-line wings. For our observations of WASP 62b, this is the second time that we have observed the full sodium feature, that is, with its line wings, in an exoplanet, and the first time that we have done so from space. But the complete sodium signature does more than tells us that the exoplanet's atmosphere is cloud-free. It can help explain how much sodium there is and indicate what other elements are in the atmosphere. Not only does it tell us that the atmosphere is clear, it can also help us to constrain really precise abundance or quantities of sodium, as well as other elements that are present in the planet's atmosphere. These abundances are useful for measuring key quantities that can help us trace back the origins and evolution of this planet. There is clearly something different going on when a cloud-free planet forms. Since there are so few of them, astronomers are only at the beginning of studying them. The only other cloud-free exoplanet that we know of is the hot Saturn named WASP 96b, found in 2018. It will be up to the James Webb Space Telescope to examine this exoplanet's atmosphere more closely, and its clear skies makes the prospect even more exciting. The Webb's advanced observing capabilities mean it should be able to identify even more of the chemical constituents in WASP 62b's atmosphere. Due to James Webb Space Telescope's orientation and position in space, it will have two small continuous viewing zones. They are centered on each pole of the ecliptic in preparation for James Webb Space Telescope. Identifying targets that are cloud-free or haze-free is important for mobilizing community efforts to observe the best planets for detailed atmospheric follow-up. Although alternative targets have since been put forward, WASP-62 is the only star in the James Webb Space Telescope continuous viewing zones with a non-transiting giant planet that is bright enough for high-quality atmospheric characterization via transit spectroscopy.